maybe to get money, maybe for a relative. Do you ever notice how different it is? When you go to babysit, you cannot think for yourself. What do you have to think for? Yeah, the kid you're watching, right? You got to constantly say to yourself, man, what kind of trouble should they get in? You're always, always, always thinking about what might happen with them. I went through a legal deposition recently about when I got hit by the car with my shoulder, and the insurance company said to me, the last question they asked was something like, how has your life changed? And I said to them, it's like having a kid. You no longer just do things for yourself and think for yourself. You have to constantly say to yourself, as a parent, what's going on with my kids? Are my kids okay? Are my kids safe? And with my shoulder, because there's a partial rotator cuff tear and because there's no cartilage left inside the shoulder, I think of things I do. And in the past, I might have said, well, I'm going to do this thing. Like one of the things I could think of is in fly fishing, sometimes we have to like climb down, I don't want to say cliffs, but small, embankments that are maybe 10 foot high or 12 foot high, and some of them are rocky. And now sometimes I look at it and I go, I'm not going down that. I'm going to go walk a quarter mile or a half a mile down river till it flattens out. And then I'm going to go cross the river and I'm going to go walk back up again, because I'm always a little leery that if I fall and I hit my shoulder when I fall, that one of two things is going to happen. Either I'll fully tear the rotator cuff, at which point it's like 6 months of rehab, or I will do that last step before I have to get my shoulder replaced. So I'm constantly changing how I think in terms of my shoulder and what's going on with my shoulder. I used to ride my bike without my helmet all the time. I never wore a helmet when I rode my bike, ever, ever, ever. And lo and behold, on this particular day when I got hit, I put like 8 staples in my head over here. And from that point forward, I've worn a helmet each day. So just knowing now that I got the 8 staples and a concussion, that I got to be aware of what's going on here. This is a pretty big deal. Well, you have spent the bulk of your life thinking arithmetically. That means thinking about using arithmetic. And as I look at most of your papers on this quiz, most of you used arithmetic. What you did was you said to yourself, okay, look, you used 25 on Monday, so if I subtract 25 from 250 and then I use the same amount each and every other day, then I can divide by 5. And there's nothing wrong with that reasoning. It's just not as powerful as the reasoning we want to get you to take. Not only is this called Math 8, but it's also called pre-algebra. We're supposed to be getting you to the point where you start to think algebraically, not arithmetically. So now I have to think about what might happen to my shoulder when I walk. When you babysit, you have to think what might happen to the kid when you're babysitting the kid. We have a puppy coming, and Ziva can be nasty to other dogs if they go near things that she possesses. So we have to constantly think about what Ziva might do. Last night, she took a chunk of my German Shepherd's ear off because the German Shepherd dared to go in the kitchen when Ziva was eating. Other than that, she's sweet. But in that moment, she can be nasty. So, likewise, you need to adjust how you think over the course of this year, not necessarily in a minute, so that you can look at a problem and say, hey, how do I solve this algebraically? We want to get you to the point where your first instinct is not arithmetic like you've been doing since you were in kindergarten. Instead, we want you to think, hey, how do I do this algebraically? So let's go through how to do this question algebraically. I think you're going to find out that it's really, really easy. Can you guys just scooch back a little bit? A little bit more room? So I like the way Leah started her quiz off. So I'm going to go with what Leah said, because Leah was trying to organize it. This is Monday, and I'm just going to put Tuesday, Wednesday, Thursday, Friday, Saturday. So it's 1, 2, 3, 4, 5. Good. And then it says on Monday that there's 25 tickets sold, right? And then what's the next sentence say?
On your question, guys, what does the next sentence say? Patrick?
An equal number of tickets were sold each day for the next 5
That's
days.
right. Now, do you know what that equal number is? No. Don't try to figure it out right now. Give it a name. The name we use is X or N or maybe T for tickets. Let's go with X. But the big thing we have to realize is it's an equal number each and every single day. Now, if I added up all the tickets sold, what do I come up with? 250. Now, if we were doing arithmetic, we would write like 250 down here. But we're not, we're doing algebra. So I look at this and I say to myself, okay, how many X's do I have? 5. And isn't it true if I add up these 5 X's plus that 25, that's all the tickets sold, right? And how many tickets is there? 250. Now, if I had just given you this equation, would you have said, man, that's a really easy question? Right? So remember what I said before, we're trying to get you to change from thinking arithmetically, by the way, is to do this, 250 minus 25, because that's Monday, is 225. Then I'm going to divide that by 5, and I get 45. This is arithmetic. It's limited in its abilities. What we're doing on the left is we're doing algebra. Algebra has tremendous power. It allows you to figure things out that arithmetic does not. Okay? First step, minus 25 from both sides. And I get 5x equals 225. And then I divide by 5, and I will get x is 45. Do you notice how it's the same steps? I minus the 25 from both sides, and then I divide by 5. In all honesty, what's the big difference between the algebraic and the arithmetic ways? The algebraic way has something in it that the arithmetic way does not. What does it have?
Variable?
Yeah, it's a variable. Early in the year, I said to you, the definition of an algebra was an arithmetic that uses a variable. So if you say to yourself, how do I do this question? If you say, well, if I was doing arithmetic, I would do this, then when algebraically, you could say to yourself, well, let's just do it the arithmetic way, but let's use a variable. Minus the 25, minus the 25. Divide by 5, divide by 5. The difference is we use that variable to represent the amount on each of the equal days. Okay? Now, you know the deal. Same quiz tomorrow. Maybe I change 25 tickets on Monday to 50 tickets on Monday. Maybe I change over the next 5 days to over the next 4 days. Who knows? I don't know what adjustments I make. But you're going to take the quiz tomorrow, and we will see how you do. The one bad thing about tomorrow's quiz is that you're not going to get it back. I'm going to grade it, and I'm going to have my son, Mr. Linquist, I guess you would say, collect it, and then I will look at it tomorrow, or I should say I will look at it Friday when I get in, and you'll take a third quiz Friday if you should need it. But how many people here are confident if you go home and you look this quiz over that you should be able to ace it tomorrow? That's how I feel. I feel like you guys are going to do really, really well. Okay? All right, so now we get into today's lesson sheet. And it's just more word problems that we're going to work on. So let's take a look at the very first question. And I want to continue on this theme of arithmetic, algebraic. Arithmetic, algebraic. Arithmetic means it uses arithmetic, numbers only. What does algebra always have in it? Variable, good. But the thought process is pretty much the same. Right? There's no great big shakes here, nothing meant to be overwhelming or anything like that. So here's the question. The sum of 3 consecutive odd integers is 15. Find the largest integer. So we did talk about with algebra, we like to set up a table. It's actually a little bit big that I drew, but we'll work around it. This will be my first consecutive odd integer. This will be my second consecutive odd integer. Those marks just mean repeat. They're ditto marks. Third consecutive odd integer. Now, when we don't know what something is in algebra, what do we always call it? N or X or whatever. So I'm going to go with N this time. All right. Now, on your test the other day that you guys did so well on, most of you did really well on the consecutive integer problem on the test, but not all of you. Now, I want you to use I want you to use arithmetic to help you do algebra. And I'll show you how you do that. This question is about odd integers. Let's see here. Gabby, what's your favorite odd integer?
7,
Okay. What's the next odd integer after 7?
9,
Good. So how would I go from 7 to 9? What do I have to do?
you go by 2.
That's right. So I'm going to go by 2 here. Now, if we got 7 and we got 9, what's the next consecutive odd integer? Everybody? 11. So then starting at the 7, I had to go up 4, right? So in other words, when I go up consecutive odd, I go up by 2s, right? And that makes sense, because 7, then an even number 8, then an odd, then an even number 9, then an even number 11. So I'm going up by 2s. N plus 2, n plus 4. What would the next one be? Guys, if there was a next one, what would it be? N plus 6. Okay. So it says here that the sum, there's the key word, sum is 15. So what does that mean? Add. So I take the first one plus the second one. There's my first one, right there. There's my second one, plus the third one, and I get 15. Now, is this a same side situation or an opposite side situation? Same side. So I'm going to go 3n plus 6 is equal to 15, minus the 6 from both sides, and I get 3n is equal to 9, divide by 3, and I get n is 3. Now, that's not my final answer. I did find out what n is, but what does the problem want me to solve?
Find the largest
The largest integer. So this guy's 3, what's this guy? 3 plus 2, 5, and then 7. 7 would be my largest integer. Gabby, I'm getting the idea there that you are looking for the sheet from the other day, right? Because we didn't get a chance to start that. I believe, based on what the last class said, that there are not any more. So what I'm going to do is print it out for you, okay? So what you can do, I'm going to get started back on this in a second, but when they're all done printing here, you can pick them up, reverse the order, because they're going to come out in reverse order, staple them, and then you have that set. Why is this not printing yet? Okay, there we go. All right, so you can take care of that, and I'm going to come up over here and put that there. All right, very good. So we now have the second question. And this is like a quiz question, or a test question, and we also had a quiz, I think, before, so you should be extremely comfortable with this question. One number is 7 more than twice another number. The sum of the numbers is 37. So here's my chart. How many numbers are in this problem, guys? 2. So I'm going to go with my first number and my second number. First one's going to be x. Now, what is an expression for the second number? Guys, what's the expression for the second number? It says here what? 7 more than twice. How would I write 7 more than twice? Michael?
2x plus 7.
That's right. 2x plus 7. So I can cross that off. I've used them all up. The sum of the two numbers is 37. What does sum mean? Add. So I take the first number, which is x, plus the second number, which is 2x plus 7, equals 37. I've used that up. The directions tell me find the number. Same side situation, right? 1x plus 2x is 3x, plus 7 is 37, minus 7. 3x is 30, divide by 3, x is 10. So, I come back over to my chart to help guide me through how to finish this problem. This guy's 10, and this guy is 2 times 10 is 20, plus 7 is 27. It wanted both numbers, so I make sure that both numbers are there. What was that?
10 and 27.
Right, 10 and 27 are the two numbers. Now, I just want you to know one last step. One of the things I find comforting, again, algebra and arithmetic are the same thing. One uses a variable, one does not. But I can use arithmetic to check myself here. What is 10 plus 27? 37. And isn't that what it said both numbers were supposed to add up to? Yeah, so I know that I got it right. Any questions about that? You know, you ever see the movie The Wizard of Oz? And everybody thought Oz was like this great superpower that almost like a malevolent sort of god, this deity, so to speak, in the movie. And at the end of the movie, what do they see that Oz is? That Oz is.
He's just a human.
Not only is he just a human, but he hides behind a curtain and he pulls levers. You know what I mean? So sometimes people look at algebra and they immediately go into the I can't do this defensive, this is too hard for me mode. And it's not true, because an algebra is an arithmetic. It's just using a variable instead. And if we shift that mindset that we talked about early in class, just like I needed to, when I became a parent, I needed to learn to think because a whole new way. I had a kid all the time. Or now that my shoulder's hurt, I need to consider my shoulder all the time. Or now that I truly did get a hurt shoulder cut on my head because I rode a bicycle, now I do put a helmet on every time. Well, likewise, when you begin to hit these questions, you need to start saying to yourself, okay, I gotta start thinking algebraically. Now, do you know when you first ride a bicycle, you fall down a little bit? Right? What do you think is gonna happen when you do some algebra questions? You're gonna fall down a little bit. To make you bad? No. It means that you're in the process of developing, you're in the process of learning. When little kids learn how to walk, they stand up. Once in a while, they hit their head on a coffee table. This is the way the world works. But you learn from it, and you get okay. It's going to be okay. You know, a little bit of pain, you'll grow from it, you'll learn. I want you to try number 1. This time we don't set up a table. How do we always handle number 1? Because it's about shapes? Yeah, we draw a picture, right? Okay, just starting on number 1. Oh, I need to get a new Avenger. Okay, so we got this rectangle, and the big thing is it says that the length is 3 more than twice the width. So an expression for 3 more than twice the width is right here, 2w plus 3. 3 more than, remember, more than or less than, last shall be first, first shall be last. So since the 3 is in the beginning, it becomes last. Twice the width is at the end, it becomes first. Twice the width plus 3. There's all 4 sides, because perimeter means add up all the sides. So if I do w plus 2w plus 3, that's this side and this side. Now I gotta do this one and this one, plus another w, plus another 2w plus 3. Altogether I come up with, does it say 70 or 78? 78. All right, same side, opposite side, what do we got? Same side, okay, so that's 1, 3, 4, 6w, plus 6 is equal to 78, minus the 6, that almost looks like a 10, that's a 6w there. Die. 6w is 72. Divide by 6, W is 12. All done, right? No, why not? Patrick? Yeah, you gotta find the dimension. So if the width is 12, that's this guy. But this one is 2 times 12, substituting for W, plus 3, and that is 27. And again, if I add them all up, 12 and 27 is 39, and there's another 39 on the other two sides, and 39 and 39, 78, using a little arithmetic to check algebra. Okay? All right, we won't have time for the next question, but remember, word problems, setup, shapes. Set up tables, if you see it's about a shape, you draw the shape, get things rocking. We're coming along really well, guys. We're also coming near the end of our study of word problems. Not that we'll ever completely stop, because we'll always do some on homework and some on tests, until we feel really comfortable with it and can kick butt on word problems. All right, keep up the good work.